Hello and welcome to this introduction to matrices video. A matrix is a rectangular array of numbers. Each number in a matrix is called an element. For example, 2, 1, 3 of the matrix, they are element. The matrix here with 3 rows and 4 columns is 3 by 4. We write it 3 by 4 and we read it 3 by 4 because it has 3 rows and 4 columns. Sometimes we deal with more than 3 and 4, could be 5 by 7 or so on. So in a matrix with m rows and then maybe n columns is called m by n columns. These here are called the dimension or the order of the matrix. So this matrix here is of order 3 by 4 or dimension 3 by 4. So consider the system of linear equation here. We can get these matrices from a system of equation. For example, here using only the coefficient and constant matrix. Coefficients here will be 1, minus 1, 3, and then the coefficient is 4, and we have 1, 0, minus 2, 10, 3, minus 1, 5, and 14. So we get these matrices from basically a system of linear equations. And so this matrix here is called the augmented matrix. And the 1, minus 1, 3, 1, 0, minus 2, these are coefficients of the system, and therefore the matrix called the coefficient matrix, and the constant here will make a constant matrix. And again, this coefficient matrix is a square matrix. Why is it square? Because it has 3 by 3. So it's a 3 by 3 matrix, and this constant matrix is 3 by 1, and this augmented matrix is 3 by 4. So it's very important to know the dimension of the matrices. So why these matrices are important? They do help us solve a system of equations easily. And let's see here this example. So consider the following augmented matrix. This is a good augmented matrix. Why is it good? Because this augmented matrix represents a system of equations that we can solve by back substitution. So if we have this augmented matrix, we can write the system back. So we write x minus y, 3 and 4, 3z equal to 4. So again, this is the coefficient matrix, and here we have 0x, we don't need to write it, so we have y minus 2z equal 1, and we have z equal 3. So this augmented matrix, which has a name of in a row echelon form, we're gonna review that later, it's help us solve this system by back substitution. Because here I know that z is 3, we just have to plug it back in the second equation, which makes y minus 2 times 3 equal to 1, which gives us that, solving the system, we gave us y equals 7. And here we can get to x minus 7 plus 3 times 3. We are substituting the two values that we just received, x, y and z, to the first equation. So that will help us solve for x. And then solving for x here, we get x equal to. So the solution to this system is we have 2, 7, and 3. And so, and now the goal is to go from a system where, and you write it in augmented matrix, and then you try to take this augmented matrix and write it in this form, which is called the row echelon form, so we could easily use it with back substitution and solve the system. So what is this row echelon form? The row echelon form is all rows of zeros are at the bottom of the matrix. So if you have all zeros, they must be at the bottom of the matrix. They can be anywhere else. And the leading term in any row, non-zero row, is 1, and all terms below this leading one are 0. So if this is the leading of this row, so these are the rows, and so the leading term must be 1, and anything below it is a 0, and the leading one in a row occurs to the right of any leading ones above. That means I can put one, there is a 1 here and 1 here, have to be always to the right. So for example, this matrix here is leading one, do not shift to the right successive rows, so this is not in row echelon form, but this one here is in this is in row echelon form. We'll continue later with the next video of how to get to this row echelon form. What kind of operation do we need to get to this echelon form? That's going to be in the next video. Thank you, and I hope this is helpful.